Find the derivatives of the given function. You look at this function, the first thing you notice is that, oh, these are all some kind of exponential. Well, let me recall something. We had power functions, which were like, okay, I have x to the power some number. And in general, it was like u to the power n. Those were the general cases that we deal with power rules when we differentiate. Then we had exponential functions when, okay, so see, in the power, the denominator is x, the power is constant. In the exponential, it's the other way around. The base is constant, the power is x. That's what exponential means. And then we had the general case, b to the power u. We know how to differentiate. But then there are more generalized cases. The case is that the denominator and numerators are two functions. Neither are constant. Something like f of x to the power gx. For this, I have a rule. For this, I have another rule. But when it comes to functions like this, f of x, a function to the power another function, none of them constant, then you need to use log differentiation. How does log differentiation work? Well, it works as this. You first find ln of both sides. And then use the properties of ln and simplify the right-hand side. Look here, if you have ln of a to the power b, you can bring this b up front and make it multiple. So it means that ln of f prime x, or ln of f is 5x squared ln of x. When you apply that rule, you don't have any power anymore there. It's just product of two functions. Then differentiate. Derivative of the left-hand side, derivative of a function, ln of a function. Maybe I recall it here. The derivative of ln x is 1 over x. But when it comes to derivative of ln of a function, it will give me u prime over u. And this will give me f prime x over fx equals to derivative of the right-hand side, 5x squared ln of x prime. And then this is product rule, derivative of first one times the second one plus the first one itself times the derivative of ln x, which is 1 over x. Why did I do all these works? Because you see, f prime is now in the left-hand side. If I multiply f to the right-hand side, I'm done with the differentiation. Oh, 5x squared over x is just 5x. I can definitely write that. Okay, so what I don't like here is that f, I have a formula for that. Why don't I put it back in? So this will be x to the power 5x squared times 10x ln x plus 5x. And that's the derivative. And the process that I did, you have to repeat in all these cases. Whenever you see a function to the power another function, log differentiation is what you need to use. Okay, so let me do the second one here. Ln of f of x is equal to ln of cosine x to the power ln x plus 4. but then I can apply properties of a ln to the right hand side, and I get ln x plus 4, the whole thing, times ln of cosine x. Then differentiate both sides. F prime x over fx equals to derivative of ln x. This is product of two things. Derivative of ln x plus 4 is 1 over x plus 0. Times a second one, which is just ln of cosine x, plus the first one times derivative of ln of cosine x. Derivative of ln of a function is derivative of that function, in this case, derivative of cosine x, which is minus sine x, over the function itself. Well, from here, I can see that f prime x is going to be f of x. I multiply this to the right-hand side, times ln of cosine x over x plus, look, this guy here is tan x. Sine x over cosine x is tan x, and there is a minus sign. I'll write minus sign there. Will be tan x times ln x plus 4. And fx that you multiplied there, I will just put the formula for fx and just save some time for us. Okay. And the same trick goes for the third one. So let me just do the third one very quickly. Here, go back to black. So this is ln of arc sine x to the power sine x. And then differentiate. Oh, well, let me simplify first. The sine x will come up front. This will be sine x ln of arc sine x. And then differentiate both sides. F prime x over f is equal to derivative of first one times second one plus derivative the first one itself times derivative of ln of arc sine x. What you need to do, find the derivative of arc sine, which is 1 over root 1 minus x squared over arc sine x. And well, this will give me f prime x is equal to, I multiply f to the other side, which is arc sine x to the power sine x times cosine x ln of arc sine plus, here I have, you see, I can multiply this and write it as a sine x over arc sine x times root 1 over root of 1 minus x squared. And that way we find f prime x that we were looking